Hello and welcome to the Math Studio. In this video, we're going to look at an interesting example involving the parameterization of a Cartesian equation. Now, in the previous video, we looked at the Cartesian equation x squared plus y squared equals 1, which is a unit circle, and we parameterized that. We end up with x equals cos theta, y equals sine theta. So changing the plus sign now to a minus sign, how does that change things? So we're going to parameterize the Cartesian equation x squared minus y squared equals 1. Now at this point, I would invite you to maybe pause the video, graph this equation, x squared minus y squared equals 1. You actually get a rectangular hyperbola. So it looks something like this. So I guess to save you a little bit of time. Okay, so you can graph this at any time, of course, and sort of convince yourself that it's going to look something like that. And it's going to intersect with the x-axis at -1 and +1. So how can we then parameterize this equation x squared minus y squared equals 1? So the clue for that is, again, a Pythagorean identity. So if you watch the previous video where I parameterized x squared plus y squared equals 1, it was based on this Pythagorean identity, cos squared theta plus sine squared theta equals 1. So let's see how we can use that to then parameterize x squared minus y squared equals 1. So splitting it up into our two equations, x and y in terms of theta. So if we take our fundamental Pythagorean identity, we divide everything by cos squared theta, you end up with 1 plus tan squared theta is equal to sec squared theta. So let's rearrange this Pythagorean identity so you end up with something squared minus something squared equals 1. So if we leave the 1 where it is, okay, I'll just do it here, is equal to sec squared theta minus tan squared theta. If I switch both sides around, you end up with sec squared theta minus tan squared theta equals 1. And this equation here is very similar in form to our original Cartesian equation, x squared minus y squared equals 1. I think that's very important to see. So this is in fact equivalent to our x squared. Tan squared theta is in fact equivalent to our y squared. So therefore, our parametric equations will be x is equal to sec theta, because we sort of x squared equals sec squared theta, so x equals sec theta, of course, and y is equal to tan theta. You can graph that also in Desmos or any other graphing software, and you should get exactly the same shape as graphing the Cartesian equation x squared minus y squared equals 1. Thank you for watching.